would like to take some questions about science or about the dance. So someone's got to cut me off for the time of 5 o'clock. I'm not sure what time it is right now. 10 minutes, okay. 10 minutes for questions, we'll have it.
2 minutes.
So the Earth is about, the Sun is almost 5 billion years old, and the Earth was a bit younger than that. And so it took up until that time for the Earth to actually form. So it was about 4 billion years ago. 4.5, give or take. In astronomical numbers, 0.5 is kind of a large, really small.
Were you skipping really fast between like 1 minute after the Big Bang to like these, or is it an exponential process?
Well, one thing that I neglected to mention is that when neutral atoms form, that happened 300,000 years after the beginning. So there's so much stuff that happens in the first little bit of time, and then after 4 minutes, nothing of true importance for well, some true importance, but the next big landmark is 300,000 years after. And then the next big landmark is 1 billion years, when you can start making stars and galaxies. It really does change that much as the time scale goes up. Do you have any questions for the dancers? Anybody want to talk about something learned?
How does it feel to be a proton?
How does it feel to be a proton?
Oh, I love being a proton. So positive.
So I really wanted to get some of the people who are dancers and scientists involved in this project too, so that they would get something out of it that I would get.
So for those people who are factoring, what do you guys get from us?
Okay, the first rehearsal was a little overwhelming. He's explaining it like I know exactly what he's talking about. And like after a few rehearsals, I'm like, okay, I know this now. I know. So the first rehearsal was
it definitely takes like an understanding. Like I know for a while we felt kind of like we understand what we're doing, but like how does it relate, kind of thing, like visually. And so definitely once that clicked up, like I don't know, for me at least, once that clicked, it was like this makes a lot of sense now. So.
I was going to make a private joke, and without the color band, you must be dark matter. That's all the blood. So what hasn't talked about much is what do we know enough to speculate when dark matter would have come into this equation?
Well, so my PhD dissertation actually was on dark matter, so I've studied that a lot. But I purposely didn't include dark matter in this because it is a question of when did it form, and it depends on how massive it is. Just like how the energy of the universe has to be right for that to happen, and it should have come around sometime during when all the other particles were forming, but it depends on how massive it actually is. We don't know yet, to know exactly what time. But it should be somewhere around in that time frame, after the forces split off and before the nucleosynthesis, or when we started having deuterium go into helium and things like that after that. So sometime in there, it should have been formed. What is dark matter? So dark matter. So along with all the other matter that we see, it looks like there actually is a whole bunch of other matter in the universe that we don't see. And it doesn't interact with us either. And so we call it dark because we can't touch it, it can't touch us. We can't see with light, it doesn't reflect light, it doesn't shine light, it doesn't cast a shadow, it doesn't give off heat. By gravity. We can see its gravitational effect because it has mass. So, and there are numerous points of evidence we have for that, for it being there. And in fact, that if you lump all the matter together, you get 85% of all the matter in the universe is dark matter, and 15% of all the matter is what we're made of. It's not everything you cannot see because there is empty space. So the dark matter does have what we call density profiles. Yes. Oh, right. So there was a telescope that we used to have in Perkins. We have a smaller telescope now, but it was a bigger telescope that was in the Perkins Observatory down the road, down in 23. And this Perkins Observatory telescope was moved to Arizona, and it was this telescope that first got some of the best data confirming that dark matter should be there. Or not confirming, I should have suggested that dark matter should be there, because it took a long time for the investigation to say that it's there. And we're pretty sure it's there, we haven't found it yet. But there is that big Ohio-West connection, and that was a telescope that was used to make these initial findings with that by Vera Rubin in the late 1960s, early 1970s.
It's antisocial matter that doesn't play well with other children.
Yes, it's antisocial matter. But it does have gravity, so it can tug on you and hit you in the playground. But, so if you have a spiral galaxy, the dark matter is actually kind of like a big sphere encompassing that galaxy. Kind of like you have a spiral galaxy inside of a big sphere of yellow. So the dark matter is throughout that whole thing, and actually extends beyond the flat gas, the flat disk of stars, gas, and dust, out to a larger radius.
Who was in charge of the choreography, or was it?
I was. So I asked, hey, can you come up with something? The question was, who was in charge of the choreography? And the answer is that I kind of figured out how I wanted stuff to go, and I said, hey, can you do this? And or we improvise this section to see if we can make this work. If you guys are the center of the sun, or be the sun, for example, how are you free to be the sun? And they kind of figured out some improvised way to do that.
For how long did you rehearse?
5 minutes. 4 weeks. It was a lot. Yeah, not a lot. It was like 4 weeks meeting twice a week for an hour each time. Which on the scale of dance performance is not very long.
Major skill.
I think it might get more confusing if I had more dancers because there might be too much going on stage. So I actually decided to limit this to 10. So I was hoping I would get between 8 and 10. I was really hoping for 10, but I figured that number would be the right number to show what I wanted to show. But if I went to 12 or more, then that would be too busy. So I had too many particles being too many things. Too much chaos. It's not the first problem.
So I bet everybody here would be really proud of OVU putting a video like this out for public distribution. So I'm going to publicly embarrass you with saying, what is your plan for getting this out there for other people to see?
What if I plan for getting this out there?
Yeah. Video, right?
Well, it depends on I have my own, right? So we are taping this, and we'll go on my personal YouTube sort of stuff, and who knows if Ohio West will promote it itself. That would be also cool thing with that, but I don't know exactly. I haven't figured it out.
Digital archives would love to have it.
Yeah. So Brittany, Brittany had a good question. She wanted to say, do you guys think you learned about the science through the dance more than you would have if I gave a PowerPoint presentation on this? So being a scientist, right, there's always an experiment going on, and this was my experiment to see if this would actually work. And so I'm really glad to hear that you got something out of doing it in this format compared to doing it as me standing in front of a screen with a laser pointer and saying, oh, the new way I do